Hi, this is Mr. Rubinstein, and this is part 4 of my review of the Math B Regents from June 2008. We're on question 17, and they have here this situation. They have a 50-degree, 50-yard length and a 30-yard length and a 120-degree angle, and they want to know how far apart are the two trees. So I'll draw my diagram. We have 50, and we have 30, and we have 120 degrees, and this makes a triangle, more or less. They want to know how big this is. Now, to do a question like this, it's kind of like the Pythagorean theorem, but because that's not a 90-degree angle, instead of using a squared plus b squared equals c squared, we use, in your formula sheet, you've got this law of cosines here. And they have it written a squared equals b squared plus b squared, sorry, a squared equals b squared plus c squared minus 2bc cosine a. The way I like to think of this question is the side across from the angle goes first, so x squared equals, here you have your two legs, so 50 squared plus 30 squared. So at this point it looks a lot like the Pythagorean theorem. But instead of just ending there, we do minus 2 times this first leg, or the side around the angle, 50 times 30 times cosine 120 degrees. So you could put it all into the calculator, but I'll do the steps out separately. 2 times 50 times 30 is 3,000. Cosine 120. And here I'll throw this all into the calculator. I get x squared equals 4,900. Take the square root of both sides, get x equals 70, which is actually choice number 3. And that is it for question number 17. Moving on to question number 18. Here they want to know how long is the length of the arc AC in feet. And you have AB is a 20-degree radius, and we have a 1 radian angle there. So let's take a look at this. So this is an arc of a circle. So if I were to draw the entire circle, it would look like something like that. The long way to do this question would be to find the entire circumference of the circle and then try to figure out, based on sort of what percent of the entire circle of 360 degrees this angle is. But since this angle is in radians, there is a shortcut. There's a formula. It's not given to you on the formula sheet, but the formula is S equals theta R, and it's perfect for this kind of question because S is the arc length, which is what they want to know. This is arc length in like length, not in degrees. Theta is the angle, the central angle in radians, which it's already given is 1 radian, and the R is the radius. That's why the answer to this question is just 20. As you can see, that is choice number 3. And that's it for question 18. Question 19, I to the 100th plus I to the 101st plus I to the 102nd. Well, the powers of I to the 0 power, like anything to the 0 power, is 1. I squared is -1. That's the definition of I. To get I to the 3rd, you multiply I squared by another I to get -I. And for I to the 4th, I like to think of it as I squared squared. So negative 1 squared gets me back to positive 1. I left off I to the first power is, of course, just I, just like anything to the first power equals itself. But they want to know about I to the 100th power. Well, the trick is for raising I to a power that's bigger than 4 is on the side you divide the exponent by 4. And what's important here is the remainder. Remember, like this thing, big R? I to the 100th will be the same as I to the remainder, which is 1. Well, I to the 101st power, if on the side I go 4 into 101, I get 25, remainder 1, so it's the same thing as I to the first, which is I, and I to the 102 by the same reasoning. It's going to be 25, remainder 2, so it's the same thing as I squared, which is negative 1. Then when you add those three things together, the ones cancel out, and you're left with just I, which is choice number 4. The final question on this part 1 is question 20. Which equation has roots whose sum is 3 and whose product is negative 4? Notice how all these equations, the a value, the coefficient on the x squared, is all 1. So there's two pretty useful formulas for a question like this, and those useful formulas are the sum of the roots is always negative b over a, and the product of the roots is always c over a. Now in all these examples, a is 1, so they would like to know when is the sum 3 and the product negative 4. Well, if the sum is 3 and a is 1, because they all have a equals 1, then the b value has to be negative 3. And they want the product to be negative 4. Well, the product is c over a, so 4 equals c over 1, or c equals 4, which means the equation is x squared minus 3x plus 4. And if you take a look, minus, did I say plus 4? This should be minus 4 because it was given the product's negative 4. And there's your answer. X squared minus 3x minus 4, which is choice 2. And that does it for the part 1 questions. Now we'll take a look, we'll get started on the part 2s. The very first question, they want you to take this graph, which looks like y equals square root of x, and they want to, it's symmetric with respect to the origin. Well, there are different types of symmetry. If it was symmetric with respect to the y-axis, the other piece would look like that. If it were symmetric with regard to the x-axis, the other piece would look like that. But in this case, they say it's symmetric with respect to the origin. What that means is that if you took a point here and you drew a line segment to the origin, and then you continue that line segment the same length and made its sort of image point there, what ends up happening is that the picture ends up looking like that. It's actually equivalent in the way it looks to what would happen if you did a 180-degree rotation. But that's why the only acceptable answer for this question is something like that. Next tutorial we'll have more part 2s, and that's going to be good for this one.